Welcome to Disrupt the Flow, your go to place for cutting edge insights on how technology is transforming supply chain. In today's episode, we sit down with Doug Mouton, a global leader in DC infrastructure and sustainability. We explore how AI, automation, and low carbon material are shaping the future of data centers and large scale industrial projects. I'm your host, Neha, and as always, joined by Julian. Welcome, Doug.
Thank you, Neha.
Thank you, Neha.
So today we have a very exciting discussion. I think the bottom line is, did you know that the global CAGR for the data center industry is estimated to be about 30% over the next 5 years? That's pretty meaningful and should have people's attention. Today's discussion with Doug will focus on a number of topics from scaling data center infrastructure, innovations in the next gen materials and renewable energy, leadership and innovation through this process, which is critical, I believe, and then the role of AI and digital tools to do all of this efficiently. So welcome, Doug. Let's start maybe by just tell us about your journey up until now.
Wow. Thank you, Julian. Well, I'm a traditional design architect. I came up on the boards before even CAD was around. I'm giving my age away. But I transitioned from design into construction through some work in the military where I was a combat engineer and I deployed to Afghanistan. I really started to learn about where my skills were. I thought I was a better construction person, was pure design. And that led me into eventually global construction with Jacobs, where I led global program construction management, and then on to Microsoft, where I got to lead global procurement, design, and construction of the data center cloud from 2014 to 2020. And then later I was able to join Meta as a senior engineering lead on the R&D side, helping rationalize what is the change that needs to happen to the data center infrastructure to support AI workloads and also to respond to Meta's year of efficiency to create a more efficient platform, where I represented Meta across the big four, across the OCP, as well as the iMasons Climate Accord, to really create a common voice across the hyperscalers about what we need from the services and supply chain within this industry to really respond to our ESG commitments across the board to reduce our environmental footprint of this infrastructure. So now I think we advise clients and try to help with sharing the good word.
Wow. Thank you, Doug, for that setup. From our time at Microsoft to now, the world has changed way more faster than we had imagined back then. AI, that's the buzzword. Can you give us more color on the latest in the data center world?
Absolutely. So yeah, Julian mentioned the 30% CAGR. It's important to recognize that the AI growth is not the only game in town. The AI growth sits on top of our high performance compute and storage, the traditional cloud workloads we've been developing for so many years, the work you and I did at Microsoft. So when we look at some of the key publications that watch us, like Jones Lang LaSalle or CBRE, it's largely thought of as like a 15% CAGR for the traditional high performance compute workloads. And we see AI stacking on another 15%.
Okay.
Building that 30% global CAGR across this industry. And the distribution of that growth is largely concentrated in North America, followed by EMEA, Europe principally, and then Asia. We don't have a lot of visibility into what China is building right now, but we know there's a lot going on, but that's generally the distribution we see. So anyone can recognize in this business to grow at a number of 10% is very difficult for organizations, processes, systems, and supply chains. 15% has been difficult, but the industry has been doing it. To go to 30 is going to require and create disruption in how we normally do business. Those that will disrupt, those that will innovate, will find ways to deliver this infrastructure against a very constrained supply chain.
Fascinating. What changes in the data center construction with AI? We hear that fundamentally the data center space for AI workflows is very different. Can you throw some light on that?
It is. Since I'm not a technical guy, I get to explain it in a very simple way. We think about high performance compute. It's really the same things we would do in our office computers, but we get to consolidate them into places where we get a much more efficient model. We get on-demand model, we get licensing on demand, and the compute power is much stronger. The storage capacity is much higher, but fundamentally the same types of tasks and workloads we would do in on-prem computer IT platform. What AI does is fundamentally different, with the two major movements of AI being to do the large language model learning and then the inference once that model is created. The beauty of what's going on with the AI models, where the excitement is creating a neural network. And when that neural network requires, due to current technology, large concentrations of high density compute power fed by GPUs, and they're connected by what we call a backend network. And that technology today has a very low latency tolerance. So these high density compute servers have to be really close together and stitched together with 5 times more fiber than we normally see at a hyperscale, high performance compute data center, which is already a tremendous amount of fiber. That, on top of the fact that we have these GPUs that are drawing down much more power and much more concentrations, the heat loads that are created are much higher, requiring a new methodology to cool these data centers. For the last 10 years, we have seen the large hyperscalers, for the most part, use air cooling because it is the most efficient way to cool the data center to reduce the PUE, the power utilization efficiency. What percentage of total power is used to cool the servers? In the past, evaporative cooling or adiabatic cooling, simply manipulating airflows and humidity, has been how the large hyperscalers have done it. The workloads now require what we call liquid to the chip. So the heat rejection outside is now much more complicated and expensive. And we are also now required to have what we call hybrid workloads. We need to be able to handle both air and liquid cooled workloads inside these much bigger facilities with all this additional density and fiber optics. So it's a lot of change in terms of density and cooling methodology.
And as a follow-up question, retrofitting and changing these existing data centers is going to be an expensive affair. How do you see these big hyperscalers deal with this transition?
Well, some of the things that you could do just to open source, you can just look at Google Maps and you can see, the designs changing. You can see, for example, Microsoft has their scalable form factor, which is typically a very long and simple building that delivers one data hall at a time. We start to see new forms showing up on the aerials. We see these much more square buildings that can get the concentration of data centers. We see also Meta changing their reference design to a larger footprint. So we're seeing the geometry and density of these buildings change. I don't think retrofitting will be the primary lever, although we do see some of the hyperscalers actually making the hard decision to remove existing servers and put in new servers, changing the use of those buildings. But we don't see the wholesale retrofit as much as, hey, let's building what we have to support that 50% of high performance compute workload. And let's start making sure our new buildings are accommodating the AI. Right now, large language models are the big play. When we get into inference, we may see different requirements going on inside of these data centers as well. So primarily we are seeing these half gigawatt and gigawatt kind of campuses announced for AI, and they're built for purpose as opposed to retrofitting right now. My observation.
Okay. Interesting. And I realize, everything that you described, of course, has an impact on sustainability, Doug, at the end of the day, especially with the energy that is used. But given or realizing that the ultimate goal at the end of the day is profitability, how are you seeing some of these companies treat sustainability and invest on technologies that can make it more sustainable at the end of the day? Because this is not a problem for next year; it's a problem for a few decades in terms of how do you manage that.
That's a really beautiful and hard question. Sustainability, I think, is a moral imperative that we all share as occupants of the planet. And I think about sustainability in two lenses: the lens of people and then the lens of planet. And I'm super proud of this industry. 10 years ago, when I first started, It was largely delivered with commercial contractors who had a safety rating in OSHA, and US standard, measures how many people you would have to send to the doctor of your
Yep.
population by census of 100. This number was like 3 point something, where 3 point something people per 100 would go to the doctors on a construction project, which is really, when we scale up, that can lead to some really bad things in terms of
It's very
high.
high. I agree.
That's exactly right. And you compare that to best in class, like the industrial industries like oil and gas, they're at a 0.5. Well, in the last 10 years, most of our providers are delivering at that 0.5 and better. So I'm super proud of how this industry has galvanized and shared best practices and created a much safer environment for our people. So we have a lot to be proud of, and we have to like hang on to that while we grow. When we pivot over to the planet side, we think about emissions, and we think about how the UN defines emissions, the scopes of emissions that are from the operations themselves, which for data centers is largely negligible compared to the others. Then we think about, which is the power, where the power comes from, and then the emissions from the operation itself. The power over the last 10 years has been really worked on a lot by everyone. You see all this investment in renewables with wind and solar. So those scope 2 emissions have really come down. The last frontier with sustainability is scope 3, the embodied carbon within the construction itself. That is the diesel that we emit to move all the earth, the embodied carbon to create the steel and the concrete and
Yeah.
the copper. This is where we focus. The thesis that I like to pursue and share about sustainability is that the way we make sustainability stick is that we make it bottom line beneficial to the company. So here's kind of a framework I think about that is getting traction. And that is, if we simplify our designs, if we make them less material intense, we get the benefit of lower costs because we're buying less materials. We get the benefit of less material to move and in place, which speeds up construction, which drives capital efficiency. With capital efficiency, we see less lead time capital invested because we get the capital investment turned into revenue faster. We get lower unit cost. And with that savings, we drive bottom line business improvement. Then we get to make the next choice. Once we're demonstrating that we're building efficiently, we can then decide, where do we invest our savings to make our profile even better? Is that low carbon concrete? Is that wood versus timber? And there are so many innovations out there. But I think that the principle that we should all think about together is thinking about sustainability as a business imperative, that if we can't make it pay for itself, it's not likely to be able to be sustainable in the long run as we see companies pressurized on cost.
Okay. Yeah. I think you bring up a great point, Doug. At the end of the day, it's got to be net positive. But I think based on what you're saying, it is encouraging that the technologies exist and the practices exist to be able to achieve that profitability. So the fact that that's happening should be an excuse to push the sustainability question aside.
That's right. We can't just like throw our hands up, say it's too hard to do. And there's some exciting developments going on I'm going to share with you. For example, while I was at Meta used open source AI to create technology to help concrete manufacturers and batch plants to use recycled materials like fly ash, industrial slag, even experimenting with lithium tailings to reduce the amount of high intensity Portland concrete that goes into these mixes that can lower that carbon and actually reduce waste streams. I just posted on some technology released by MIT where the production manufacturing process for aluminum is found some new technologies of filtration, nanofiltration, that can take the waste stream used to create aluminum and actually create more aluminum from it and then reduce the waste streams as well. So there are so many different things we can do. I can talk about timber, where timber is now from a cost point at parity or lower than steel. So we should be driving that down because it holds carbon in it. And on top of that, we're seeing steel being produced by renewable energy, which means it has a lot less carbon as well. So there are so many things we can do that drive bottom line benefit and increase our social responsibility. I'm excited about the opportunities ahead of us.
Excellent.
Thank you, Doug. That was Excellent. And you do talk about the scale and pace at which data centers are going to be built with these new workflows. What are some of the common bottlenecks you've seen in the data center supply chain? What if I'm somebody who's thinking of building the next generation data centers, what are some of the things that should be top of my mind from a supply chain enablement perspective?
Yeah, absolutely. Well, I'd start with simplification. The more we can simplify our designs and remove redundant systems, obviously we have to meet the availability requirements. We have to meet the physical requirements. We often find data centers are systems of systems. And if we don't have deep curiosity as systems integrators, we often can find that many systems will be providing redundancies that collectively may overachieve what we need. These are great examples we could talk about, but I don't want to get lost on details. I want to talk about just the notion of simplification and systems reduction and elimination is critical. We can do a lot of good there. So assuming we have the most efficient, simple design, the bottlenecks come up in two flavors for me. It comes up in the form of skilled labor shortages on site, and it comes up in the terms of long lead items that require the providers to have a much more proactive thought about how capital delivery should work. Before we got into AI workloads and a big pivot to heat rejection to liquid medium, meaning cooling towers, dry coolers, much more gear. Before it was generators. Generators had like a 52-week or better lead time, depending upon what time of the year you're at or what the demand is. I think generators will still be a long lead item and have to be managed very carefully. Or backup power, more broadly spoken. But also, I think the big major end items to provide the cooling, particularly dry coolers, they take a long time. They're very expensive. So I think now we have a more mechanical cooling system. We're going to add a whole new cadre of equipment suppliers and kit that needs to go in there. The lead times themselves need to be carefully considered. So the smartest providers will be looking at the macro level of their programs and coming up with supplier relationships that give predictability to the supply chain. Often our big customers, they have the power of the purse. They can behave in a way that's like, hey, I need this now. I'm your big customer. I don't think that's going to work in a high demand situation. We have to be good customers, give our supply chain as much lead time as possible, and try to give them requests that fit within their standard solution sets as much as possible. The least amount of customization that we can impose on the market, the more likely we will get a more predictable flow out of the supply chain. On the labor side, it's a matter of looking at where are we building and how hard is it to get the concentrations of labor in one place. And design can absolutely inform procurement. If we are building in a modular way, if we're building in a way that allows chunks of capacity to deliver versus trying to get to a big stair step, I need 100 megawatts now, will greatly reduce the head count required on site. So we can keep a smaller team busy more productively on us versus expecting I need 1,000 electrical contractors and 3 weeks later they're coming down. I'm being a little facetious, but creating these big spikes really jerks around the labor market. Predictability, stability, and smaller teams informed by a design strategy that delivers in data hall sized chunks are deliverable at the same, slightly faster than the speed we can deliver servers, right? At the end of the day, capital expense converts to revenue when we have blinking lights in a data center. And understanding the velocity that we can receive these GPUs and CPUs and get them lit up informs how fast we really need to deliver our infrastructure. And we should give the supply chain as much time as possible to deliver it to us in a sustainable, feasible way.
That makes a lot of sense, Doug. And you talk about material shortages and component planning around supply chain, as well as labor shortages, connecting dots with digital transformation that you spoke about. What are some good examples of robotics, RPA, predictive analytics, automation have you seen to serve some of these material planning as well as labor shortages in place?
So great question, Neha. What I've seen in practice is more using technology to transform construction on the management side in terms of how do we see ourselves and how do we manage the work. I had not seen a lot of scaled traction in terms of robotics on the job itself. So let me tell you what I have seen.
Okay.
Look, the big art of delivery is understanding scope, schedule, and quality. How are we obviously underpinned by safety always? And what we are seeing is the ability to connect schedule to cost very clearly with work breakdown structures that allow us to tie that to our BIM models, which is the digital models that we build from and design to. And we have some really great examples in our past life at Microsoft where we saw, and others are doing this as well. We see laser scanning going on at periodic intervals on the job site that can precisely capture from a point cloud to a vectorized image that overlays over the standard design so we can see exactly progress to date. We can see variations for placement of materials and systems, so quality is increased. And using this technology, we're also able to do something even more powerful, and that is to begin with the end in mind. We can start our project with this connection of cost and schedule, and we can animate what the construction looks like. And when we do that, we can create this four-dimensional view, the story of the project. And when our project managers become the protagonists of the story, they understand where the crises are expected to happen, where the risk is, what will we do to manage through it. And when that project manager, he or she can see the project from beginning to end visually, they can then share that with the team. The team can have a common operational picture, a common understanding. And with that, we can see challenges before they happen. We can allocate time and resources against future risk, and we can decide if that risk is on us or if it's behind us. And we can decide what to do with that resource we allocated. This becomes some of the most sophisticated elements of delivery. And through this higher plane of management, we can then reduce waste. We can improve productivity. We can improve quality. And most importantly, since we know where we all are on the project over time, we can also keep our people safer. So we observe that our safest projects are the most well-planned projects. So like sustainability, to make it stick, when we talk about safety as a sustainability element of people, we know the best way to keep people safe is to have detailed planning. We know that digital evolution is helping us now with that, and we're seeing a lot of benefits. I can tell you about contractors I work with in North America and in Europe to say, Doug, when we got serious about safety, our profitability increased, our productivity increased, and now it's how we're doing business everywhere. So I'm very proud of how tech has already influenced that. But Neha, to your point, what's next? Will we see other technologies to help us actually do the physical work? Yes. Watch this space. We'll see what all this 30% CAGR kind of fuels in terms of innovation and disruption.
Yeah, that's great, Doc. I think, yeah, I like the framing that you had in terms of it is improving the planning aspect of it, the technology, but you still haven't figured out, right, the people sides or in terms of you still need people to be trained and to be ready to follow that plan, right? So I wonder how much training there is given that this is such a strategic um, part for overall for the US. So, and then more broadly, Doc, like anything that you can share from your lessons, because I mean, as you mentioned, you were in the military for a while and then you moved to corporate, right? What are some of the lessons learned in making sure that the scaling of these projects happens in the best, or at least in the planned way?
Great question. Thank you for asking. So just to be clear, I spent 32 years in the National Guard, which is like a part-time soldier. Sometimes we have to serve, sometimes we don't. I was able to be an architect, and I got pulled away to go to Afghanistan, and then I did Katrina for the Superdome and the whole, hurricane and the recovery afterwards. So a couple of things. Going to Afghanistan was brilliant because it started to show me the complexity of delivery. And I learned I was probably better at that architecture, as I mentioned, but sadly, it also taught me the value of human life. When you have to tell a family member that their soldier's not coming home, that is a powerful, life-changing moment. So that experience coupled with the work I did at Jacob Engineering, which is a very safety-focused industrial engineering construction company, I really came to tech with a deep ethos around safety and the value of human life. What I learned in Katrina in the Superdome, we're just trying to take care of 30,000 people and get them out of there. We did a poor job. Is the value of human dignity? What is the way that we take care of people? And this manifests on our delivery sites as well. We'll look at work camps. We'll look at global deliveries from India to China to Japan to North America. How the workers are treated impacts greatly how they feel and their productivity, their mental health. Construction workers are probably one of the highest at risk for suicide. So this idea of human dignity and how do we care and respect their work live deep within me. Well, we're able to connect that to the thesis, hey, if we get safety right, we actually see productivity gains. We actually see financial gains. That was like the real sweet spot for me in terms of lessons learned. A lot of things came together. And to see that influence across the industry on the backs of the large build programs like Microsoft and others have done makes me very proud to be part of this industry.
Yeah, and I think that extends to pretty much any manufacturing industry at the end of the day, right? You have to take care of the people and
it's
the
all
human
about the
thing that it
people,
point.
right? Yeah.
Excellent.
So we will transition to our favorite question, Doug. What are the 3 books or podcasts that you would recommend that anybody who's interested in understanding more about your space should absolutely listen to? Or
Oh
read?
my goodness. This is like a difficult question because there's many, many more people more well-read than me, but I would go to some basics. I would look at a book like, this is going to sound crazy, Marcus Aurelius, Meditations, written thousands of years ago, but it tells the story of how to be a better human and how to really make sure you're bringing your best self to everything you do. This is 130 AD, Marcus Aurelius is on the Gaul front. He's getting his butt kicked by these barbarians. And he's not writing about the troubles of the day. He's writing about how do I become the best person possible? How can I really let people be their best? So that's one. Another one I love because I'm a military guy is Sun Tzu, The Art of War, because it has so many deep lessons in terms of like, see yourself, see the enemy. It can translate to see myself, see the opportunity or the problem I'm trying to solve. When you have the high ground, sheath your sword, try to be generous and kind when you can. Many books like that are super helpful. Another book I read is is the Metaverse. It was written by a strategy leader from Amazon, actually. But even though the Metaverse is kind of controversial, it's a window in this next generation of computing where we'll see almost as much back and forth traffic as we get to inference as we do kind of like the push out. The cloud, as we know today, is like pushing out a lot of data. As we start to infer large data bits, how does that come back and forth? And that book gives a lot of insights into how the transition might look like when we go from large language models into deeper inference, which in my opinion could make the edge much more important to us as we go forward. So those are 3 books I would say are interesting and worth looking at.
This was an amazing discussion. Thank you, Doc. Super helpful. And thank you for all the insights that you brought in. I mean, anything you would add for our listeners before we wrap up?
Well, I would just say this is a very exciting time to be part of this market and industry. And I think we are in a rare space and we should recognize that this comes in once in a lifetime for many of us, maybe none of us. And what this industry can do is innovate and also share and benefit the whole of the construction and supply chain market, not just technology itself.
Thank you so much, Doug. This has been very enriching for Julian and I, and I'm sure others are benefiting from listening to this as much as we did. Well, if today's discussion sparked new ideas for you, connect with Doug on LinkedIn. We will post all the links and references to the books he mentioned, as well as his profile. And please continue to follow Disrupt the Flow. We are committed to bringing more speakers like Doug who will help us learn more and grow alongside. So thank you very much, Doug, and thank you, Julian.
Thanks for having me. Appreciate you guys.
Thank you.